So we talked about the three properties of logarithms last time. Today we're going to use those properties to do some challenges, I guess, with when we work through assignment number 8. Just doing several things with logarithms just so we get a better understanding of what logarithms look like, how they and how they operate. So let's just go ahead and start by taking a look at number 1. Each one of these, I would suggest that you turn off or pause the video for each one. Try it on your own and see if you can do these problems on your own before starting the video up again and seeing if you can get those, see if they match with what we came up with together. So here's how I would, several ways to do number 1. The first thing you could do is you could take the log base 3 of 3, which is 1, and then we could multiply that times 2, because it's 2 times the log base 3 of 3. We know that that is 2, minus the log base 3 of 9. Well, the log base 3 of 9 means 3 to what power gives you 9, and that's 2. So we have 2 minus 2, which is 0. Another way that we could have done this is I could have moved this 2 out in front and written it as the log base 3 of 3 squared. Well, 3 squared here is 9. So that's the log base 3 of 9 minus the log base 3 of 9. So that would be the same thing. You know, they're the same thing, so you can tell by subtracting them that you're going to get 0. But we can go through this a little bit further. Since we're subtracting here, we're going to divide the 9s. So that's like the log base 3 of 9 over 9, which means 3 to what power gives you 9 over 9, which is 1. Well, we know that 3 to the 0 power gives you 1, because anything to the 0 power is 1. So there's another way that we can see that this is equal to 0. Let's take a look at another one. Log base 2 of 4 over the log base 2 of 32. Well, one way that we can do this is we can say 2 to what power gives us 4? We know that that's a 2. 2 to what power gives us 32? That's 5. We know that the answer, oops, this is minus, 2 minus 5 is negative 3. Another way that we could have done that is we could have taken the log base 2 of 4 over 32. That's a 32. Getting in a hurry here, I guess. So 4 over 32 reduces to 1 over 8. So we have the log base 2 of 1/8, which means 2 to what power gives us 1/8? Well, we know that 2 to the negative third. 2 to the third is 8, so 2 to the negative third is 1/8, which means that this has to be equal to negative 3. It's another way that we could figure out that this is equal to negative 3. Let's take a look at number 3. Suppose the log base 5 is 0.699. Well, what's the log base 25? We're supposed to use this without a calculator just by thinking about what is going on here. So we have, this is a base 10. It must mean that 10 to this 0.699 power is 5. So here we have a base 10 also. 10 to what power gives us 25? Well, this is the same thing as if we write it as the log base 10, or the common logarithm of 5 squared. That's the same thing as 2 times the log base 10 of 5. We know that the log of 5 is 0.699. So this is the same thing then as if we substitute 0.699 in for the log of 5, because that's what it's equal to. 2 times 0.699. And if we take 0.699 times 2, several ways to do this. This is 18. That's 18, 19. If we add the 1, that's 12, 13. And it would be 1.398. So we can do this without a calculator simply by multiplying the 0.699 times 2. These are the kind of things that our homework is going to be like. And so they'll also be on your quiz tomorrow. So you want to make sure that you're able to do these things without a calculator. So same thing. Log base 5 is 0.699. So let's see if we can write this somehow in terms of the log of 5. So because we're subtracting, we know one of the properties, the quotient property, is that this is the same thing, I'll write this over here again, as the log of 10 over 2. Well, the log of 10 over 2 is the same thing as the log of 5, because 10 divided by 2 is 5. We know that the log of 5 is 0.699, which means this expression is equal to 0.699. And we didn't need to use a calculator at all. We just knew that it was the same thing. Let's try another one. We want to write this expression as a single logarithm, which means we're going to simplify it. So here's what I'm going to do. I'm going to take all the exponents and write it as log of 3 to the second power. This one here is going to be minus, I'm going to take the 1/2 and write it as the log of 4 to the 1/2 power. So 4 to the 1/2 power, that's the same thing as the square root of 4. And then, that's a 2 there. And then plus, this is the same thing as the log of 9 to the 1/2 power, which is also the square root of 9. So let's simplify each of those a little bit. The first one, the log of 3 squared, well, that's the same thing as the log of 9, because 3 squared is 9. Minus the log of 4 to the 1/2 power, that's the square root of 4, which is 2. Then plus the log of 9 to the 1/2 power, that's the square root of 9, which is 3. So we could write this as a single logarithm by taking the log of 9 over 2, that's the first two logarithms, 9 divided by 2, times 3. Well, 9 over 2 times 3 is the same thing as the log of 27 over 2. I don't know why my pen's not working very good here. Log of 27 over 2. And that is how we can write this as a single logarithm. Let's take a look at number 6. So I'm going to start rewriting number 6 as 1/2 times the log of x plus 1/2 times the log of 4, and then it's minus 3/2 times the log of w. Well, then I'm going to go through and change all of these coefficients, and I'm going to write them as exponents. So this is the same thing as, oops, that shouldn't be there, as the log of x to the 1/2. Well, I'm going to write that as the square root of x. And then plus the log of 4 to the 1/2. Well, that's the square root of 4, which is 2. And then minus the log of w to the 3/2. Well, that's the square root of w to the 3rd. And so now I'm going to write this as a single logarithm. I'm going to start by taking these two and multiplying them together. That's the log of 2 times the square root of x divided by, because I'm subtracting here, divided by the square root of w to the 3rd. Now that's great, but I want to simplify this expression. I can take the w to the 3rd and write it as, I can have the radical 2x, or 2 times the square root of x. I can pull one pair of w's out, and one w is going to remain inside, but I want to rationalize the denominator, which means I'm going to multiply the top and the bottom by the square root of w. So my final answer then is going to be the log of 2 times the square root of x times w over w times w's radical w times radical w is another w, so it's w squared. And that's how it would look in simplified form. Let's take a look at one more. Here we're going to expand this. So the first thing I'm going to do is get rid of the radical sign. I'm going to write this as, I'll do it over here first, the log. I'm going to keep it all as one logarithm. So log base 4, but it's going to be x to the 5/2, then y, that's a half there, y to the 7/2, Then I have z to the first and w to the fourth. So a couple ways that I can do this. I'm just going to take all three of these, and I'm going to write 4 separate logarithms. The first one is going to be the log base 4 of x to the 5/2. Then I'm going to add to that, because this is in the numerator, I'm multiplying, the log base 4 of y to the 7/2. Then I'm going to subtract, because this is in the denominator. It's the log base 4 of z. And then I'm going to subtract again, because this is in the denominator, I'm dividing it. It's going to be the log base 4 of w to the 4th. Then I probably want to go through and get rid of all of the exponents, and so I could write it like this. We have 5/2 times the log of 4 to the x power, plus, then I have 7/2 times the log of 4 to the y, of y. I may have said that wrong before, earlier. Minus, it's just 1 times the log base 4 of z, and then minus 4 times the log base 4 of w. And if I expanded it all out, I should get something that looks like that. This is what our homework assignment is going to be about. We're going to be evaluating them, simplifying some difficult ones, expanding some difficult ones, in order just to work with logarithmic forms and get better acquainted with the properties of logarithms. So that's what our homework is about. Good luck, and we will talk to you tomorrow in class.